Okay, so we are here in YouTube. So I'll just take a moment for you guys to start the stream or get into the stream. I'm going to just set up a couple of things and then we will start. Okay, so I'm just going to disable the chat for now. And if you miss anything from the video, remember, because it's on YouTube, the video will get saved onto YouTube and you can watch the video as often as you like, as many times. I'm not going to delete the video. And then if you still need any clarification and stuff like that, you can direct message me on Sector as well. But so far we've got 20 viewers so far, and if you can have a look at the background, I'm not at school, I'm actually at home. Well, each day I'm going to visit a different city, and what we'll do is afterwards, when we go back to Teams, see if we can get the first person to try and guess what city background I have there behind me. But yeah, let's just get into the lesson. So we're already at 2:26. Let's get into it. So what I'm going to do is check that we are right to go. The YouTube stream seems to be fairly healthy at this stage. I'm not getting any red bars. So that's good. Green is good to go. All right, let's get going. Just do one thing in here. I think that's a bit of a notes journey, and we looked at compound interest, and we did a bit of simple interest first, and then we looked at what the difference is between simple interest and compound interest, and we did this table, and the table took forever because not only was the computer lagging, but this process itself took forever. And then I introduced you to this formula which gets to our result a lot quicker, and we just did a practice question in Mentor with that compound interest formula. And then we did, here's another example that I did afterwards. I attached that to the notes to help with the exercise question that you had. And then today we are doing a bit more, and I'm going to test this out at home with my better internet connection. We should be able to not have as many laggy issues. So here we go. Let's see how we go. So today we are looking at, this is an extension topic, there's no doubt about it. So this is more difficult compound interest problems. Compound interest problems. Because in your math space, you would have noticed that there's several questions towards the end that they became a bit harder because you needed to understand what some of the words meant and stuff like that. And then I said, no, don't do the math space questions just yet until I teach this thing to you. Okay, so if you can't remember the original problem in our notes, I'm going to scroll up again so you can see it. We have Alice borrowing $100,000 and it's for a business, and interest is compounded annually. The key word in this first bit is annually. Annually meaning once a year at 7.5% for 10 years. That was the initial setup that we've got. So the question I want to pose is, what if the interest is not compounded annually, but some other form of time word? So for our next example, we're going to look at what happens when the interest is compounded monthly. And all I'm going to say at this stage, I'm just going to write this down. So what if the original loan of Alice's was $100,000 still, so that doesn't change, but the interest is compounded monthly. I'll explain what that means. Instead of annually. So the words compounded monthly is referring to how often the interest is calculated. So when it was calculated annually, it meant that the interest was calculated once every year. When it's compounded monthly, it means we're calculating the interest every single month. And because there's 12 months in a year, it means that the interest is going to be calculated 12 times a year. So for this particular example, let's keep the interest rate at 7 points being the difference in this question. So the interest rate, we're going to keep it at 7.5% per annum or per year, and then the time is 10 years. We're going to keep those two things the same. So the question I want to say now is, how much does Alice have to repay after 10 years? And it's so much nicer working on this computer because there is very little lag and it's working great. Okay, let's do this. So I've got another table, all right? Now, I wouldn't recommend you do these problems with a table, and the reason why I don't want to recommend you do it with a table is because the table method is slow, but it shows you what's going on, okay? So in my table, I'm going to say in this first column, instead of it being years, I'm going to say it's months this time because it's dealing with the interest being compounded monthly. So we're going to deal with months. So our months are going to be in this column over here, and we're going to keep going down. Every single row is another month. This column is going to be the same as our first column, first table, in terms of it's going to be referring to the balance. And the start of the first month, the balance was $100,000. This is our loan amount. This next column is going to be where we multiply our interest. So this is going to be monthly, spell that right, monthly interest rate. And we'll get to that in a second. And the last column is the amount at the end of the month, and then add it on to the balance, and then repeat that process for 10 years. Let's just get started. But you're probably thinking, well, this is going to take almost 10 years just to work this out. But let's just talk about this monthly interest rate, okay? So this column here, this monthly interest rate calculation. So if the yearly interest rate is 7.5% per year or per annum, I'm just going to write that over here. So the yearly, I'm going to go a bit of a thicker marker. Let's go to green. Or maybe not. Maybe you have to select the marker with a mouse. Okay, apologies. I'm just going to do this. When my OneNote doesn't select a marker, I've just got to quit and then go back in again. All right, all good. Okay, so we're going to go yearly interest rate. So the yearly interest rate is 7.5% per annum, okay? So that's every year, that's what the interest rate is. But in this question, because we're dealing with the words compounded monthly, we need to work out the monthly interest rate. So we need to do a calculation over here to calculate how much the monthly interest rate is going to be. And all we do for that is we get the yearly interest rate, the 7.5%, and we want to divide by how many months there are in the year. So we get the yearly interest rate, so 7.5, and we want to divide by how many months there are in the year, so that's 12, and then the monthly interest rate is 0.0625%. And that's not per year anymore, that's per month. So what we're going to do is in our table, we're going to now do the same process we did last time, but instead of doing it year by year, we're going to do month by month, and we're going to use the monthly interest rate. Okay, so the monthly interest rate is 0.0625%. So what we're going to do is we're going to multiply that 100,000 by 0.0625%. So we get the balance, the $100,000, and we're going to multiply it by the monthly interest rate. And that's, in this number here, is going to tell us how much interest is added on to the loan in that month. Okay, so it's just going to calculate the interest for that month. And I got $625 interest for that month. Next up, the amount owed at the end of the month is going to be the interest plus the balance. We're going to add the balance and the interest together, and that's going to tell us how much is owed at the end of the first month. So if we add $100,000 to $625, we get $100,625. That's good maths. All right, we're ready for the next row. So the balance for the start of the second month, is going to equal the amount owed at the end of the previous month. So we're going to go $100,625. And this time, we're going to work out what the monthly interest rate is on this amount. This is how compound interest works. We keep doing the interest on whatever the current balance is each time. Okay, so it's 100,625 times 0.0625%. And if you do that right on your calculators, making sure you use the percent button, you get this time $628.91. And so the amount owed at the end of the second month is going to be these two numbers added together. So the balance at the start of the month plus the interest is now how much is owed at the end of the second month. So if you add those numbers together, you get $101,253.91. And if you keep repeating this process a few more times, I will just do this one last row, 253.91 times 0.0625%. So for the third month, we end up getting $632.84 interest. And if we add those two columns, the second and third columns together, the balance or the amount owed on the loan at the end of 3 months is going to be $101,886.75 with a bit of rounding. Okay, so we do this process repeatedly over and over and over again. In each row, we would calculate the monthly amount and so forth. But the only issue is we have to do this for 10 years. How many months are there in 10 years? Yes, it's 120 months. So if we were going to do the table method like this, we would need 120 rows. We would need 120 rows, and this last row we would get to our answer. And I'm sorry, but I don't want to go 120 rows worth of this. This is painful enough as it is. So this is 12 months for 10 years. That's 120 months. That's what that 120 is. So in order to figure out this number, the amount owing at the end of 10 years, there's got to be a better way. And there is. And I did introduce you to the formula last time, but we can't use that exact same formula. We need to adjust it a little bit. We need to adapt it to be able to cope with this type of problem. Okay, so now I'm going to introduce to you the new and improved. Let's see if I can change the thickness of this. Perfect. Okay. But it's great for answering these type of problems, because otherwise you don't really want to have to fill out the table over and over again. Okay. So this is the new and improved compound interest formula, and you can use this for any problem compound interest question, including the simpler ones as well. You could still use this better formula. It's better in a way because you can deal with the harder problems, but it is a bit more complex. Okay, here we go. Starts off A equals, that's exactly like the last compound interest formula. A means the total amount to repay. That's not different. P, that's the same as the last formula as well. And then we go 1 plus. So far, so good. Nothing is different, okay? But now this is where it gets a little bit trickier. So because in this first question, or in this question we had to deal with monthly interest, or the interest was compounded monthly. So what we need to do in this interest formula, in the interest part of the formula, is we need to divide the interest rate, the yearly interest rate, by the number of months. But sometimes the question might say the interest is calculated daily, or the interest is calculated semi-annually. The words change depending on the question. So I can't just say always divide by 12, because it's not always divide by 12. So what we're going to do is we're going to get the interest rate percentage, and we're going to divide it, and I'm going to introduce a new letter to you. I'm going to call it the Q value, and I'm going to explain what the Q value is in its own special little table in a second. So we need to divide the interest rate by Q, and then we've got to the power T again. But just like in my table here, I can't just go to the power 10, because here in this table, there's not going to be 10 rows of calculations that we're doing. It's 120 rows of calculations. So I'm actually multiplying the year amount by how many months there is. But in my formula, I can't just say t times 12. I can't just put in the power t times 12, because depending on the question, the power is going to change depending on what this, how many times the interest is calculated. That's the bit that's going to change. So what we're going to do in our formula is I'm going to multiply the time number in the power by Q, and I'll explain what Q is. We'll write down what these bits are. So I'll do this really quickly. A is the total amount for your investment, if it's an investment problem. These questions can still be that. It's basically your starting dollar amount in the question. Next up is the R value, and this is the yearly interest rate. Okay, notice I've used the word yearly there, so yearly interest rate. T is the number of years of the loan or the investment. So all these exactly the same as what we had before. And then in orange, I'm going to change it up a little bit. Q is, it stands for the number of times, and this really does depend on the different questions, the number of times the interest is calculated per year. Okay, so what I mean by that is different questions will have different words to describe this Q number, okay? So over here, I'm going to do a little table over here. I'm going to call it Q values. And I'm just going to put a little box around it, like that. And these are the different common words you're going to see in these type of compound interest questions, okay? So the first one you're going to see a lot is this word annually, compounded annually, just like the couple of questions we've had in our mental today, and the first one that we had the other day with the loan, compounded annually. That just means the interest is calculated once every year. So we're going to have a Q value there of 1, okay? So every single time you see the word compounded annually in the question, you could either use the simpler compound interest formula, or you could use this more complex formula, but just substitute Q equals to 1 into the formula. The next type of problem you might see is semi-annually. Whoops, might help if I could spell. For this one, I'm just going to make my Q's line up a bit better. This means that the interest is compounded or calculated 2 times in the year. The word semi meaning like half of or 2. So in this instance, Q is calculated, or the interest is calculated 2 times in the year, so our Q value is going to be 2. If you see the word semi-annually, you just use 2 in the formula for Q. The next type of problem you might see is the interest is compounded, and the words they might use is quarterly. So that means the interest is worked out 4 times a year. So if the interest is calculated 4 times a year, we did a Q value, a Q number that's equal to 4. Another word that's often used in these type of questions is the interest is compounded monthly, like we just had. So we would have a Q value for monthly of 12, because there's 12 months in a year. And there are more you can have, like you can have fortnightly and 3 times a year, that kind of thing, triannually. But I'm going to go from monthly, and I'm going to go straight to daily. Daily is the last one we're going to put in our table. So this means that the interest, if it was compounded daily, it would mean that the interest calculations are worked out 365 times in a year. So for maths problems, we don't include leap years. We don't worry about leap years. We always just use 365. But real banks in the real world would actually work out leap years and stuff like that, and they'll have their interest worked out accordingly. Okay, so with that in mind, so that's our Q values and our compound interest formula. What we're going to do is we're going to investigate Alice's loan that we just were talking about, and look at the differences between if the interest was compounded annually, semi-annually, quarterly, monthly, and daily. And for this one, I'm going to just fast forward a little bit. So I'm going to just jump to my thing over here. And I'm just going to take a chunk out of here, so this will be a bit quicker. And then I'm going to explain all this. So just bear with me. Copy. And then back over here. And I'm going to paste. See if this works. Beautiful. Okay, all right, let's make the screen bigger again. And let's talk about this. All right, so I won't go through this too quickly, but I don't want to do the same thing repeatedly over and over again just to change one little thing. So that's why it's going to be a bit quicker for me to do this up on the screen this way. So here's the first of 3 examples we're going to do. 2 of them are in my writing, and the third one we're going to do using a maths-based example, because you're going to still do some maths-based questions for me today as well, if we've got time. So the first example is this one. It says, investigate Alice's above loan and compare the total amounts to repay if the interest was compounded annually, semi-annually, quarterly, monthly, and daily. We've actually done a couple of these ones already. We did annually right off the very first example was an annually question where the interest was calculated once every year, and we just did monthly in the table above. At least this way we're actually going to work out the answer to that. Okay, so here are our things that are going to stay the same. So the principal is $100,000. That's not going to change for each of these different scenarios. The yearly interest rate, again, that's not going to change for each of these examples. And the time for the loan is 10 years. That's not going to change for each of these examples as well. These are going to remain fixed, okay? So in our formulas, wherever you see a P, it's going to be 100,000. Whenever you see the R percent, it's going to be 7.5%. And whenever you see the T, it's going to be 10 years. It's just this Q value that changes depending on the words in the question. So if the question was to say, Alice's loan is compounded annually once a year, this is what it looks like. It's the P value is $100,000. That stays the same. 1 plus the 0.075 is the 7.5%. That stays the same. But instead here I'm dividing by what the word annually means, which is 1 time a year the interest is calculated. So I'm dividing by 1. But I'm also multiplying the time by 1 as well. And as you can see, this formula can handle this problem easily, because it's essentially the same as the easier formula that we did the other day. 100,000, 1 plus the interest rate to the power 10. Nothing really much has changed there. So we get the same number we got the other day. But what if it was compounded semi-annually? So semi-annually meaning that the Q value is 2 this time. Notice I'm dividing the interest rate by 2 because for semi-annually, the interest is calculated twice a year. So we need to work out what the interest rate is for half a year at a time. So that's why we need to divide the interest rate by 2. But then we're doing it for 2 extra time periods. So we need to multiply the time by 2 as well. Okay, so if you did that, Alice would have to repay a total of $208,815.20, a bit more than if it was just the interest was calculated once a year. Okay, that's semi-annually. Quarterly, meaning that the interest is calculated 4 times a year, means in the formula we need to put a Q value of 4 this time. So notice we've got Q as 4 this time. again, we're going to divide the yearly interest rate by 4, because that's what quarterly means, 4 times a year. But then we're also going to multiply the power in the top of the formula by 4 as well. So always remember to divide the interest rate, but then also multiply the number of years by the Q value. That's how this formula works. And you can see there, it's a bit more than what it was for semi-annually and quite a bit more than what it was for annually when the interest was calculated once a year. The last couple is for monthly. This is what it would be. If we extended that table that we had 120 rows, we would get to this number here, $211,206.46, a lot quicker using this formula. So all we did was we divide the yearly interest rate by 12 and we multiplied the power, the time, the number of years by 12. Okay, that's how you get the amount owed for if the interest was compounded monthly. And then the final one. This one's an important one because banks actually use daily compound methods when they work out their loans. So, and the reason why banks do it is if you think about it from their perspective, if they're lending money out to people and you see these money amounts just going up a little bit each time, if you want to get the most out of people to pay, if you want the most amount of money back from people, if you lend the money to them, you want to compound the interest more and more often. And the most that they can do legally is daily. And that's what they do. They compound daily, and this is what it would be. So we're going to divide the interest, the yearly interest number. So in the formula, this is the yearly interest. We're going to divide it by the number of days in the year, which is 365. But we're also going to multiply the power, the number of years, by 365, because that's how many times the interest is going to be worked out over the 10-year period. And so they get a total of $211,683.69, which may not appear that much more than compounded monthly, but it is, and it's an extra $400. And if you multiply that by all the people that have loans around the world, it does make a difference and it does add up. And that's why the banks make so much money from loans, because people have to pay back just that little bit more than what they would have to normally do if it was calculated via simple interest. Okay, so that is that example there where we looked at all the different words and what they meant in terms of the Q values. And the Q values are just here in the notes. I'm going to keep them there. And we've just got a couple more, one more handwritten example to do, and then I'll do a maths-based example, and then we'll jump over to Teams again to do some questions and answers of the last little bit. Okay, so this one here, let's go, I might, to save some cell, no, let's just write it out, let's do it. Okay, so Luke wants to save up some money to buy the latest console when it's released. And so this year the rumor is that Xbox and PlayStation are going to come out with new consoles. So it's kind of relevant in a way, but I'm going to say for this particular question, the new console is going to be released in 18 months' time, which may be true with the coronavirus, you never know. Luke estimates that it will cost about, now my number that I'm using here is going to be a little bit off as well. I did a bit of research and the new PlayStation is going to be about $500 US apparently, but I'm just going to write $500 here as well. But I know the exchange rate in Australia and US is very different, and it's more likely going to be maybe around about the $750, $800 Australian price range. But don't quote me on that. It's all rumors at this stage. So the question is, so Luke wants to save up money to buy the latest console. It's going to be released in 18 months, and he needs around about $500. The question is, how much does he have to deposit now into an investment account or into a savings account so that the money grows to $500 by the time that the console is released? So the question is, how much money should Luke invest? I'll write invest, but it's more like deposit at the Kingsway Bank if their interest rate is 4.5% per annum and banks compound daily. Okay, so let's talk about this question and talk about the steps that you need in order to solve this question. Okay, so the first thing is what we need to do, and this is the step with all these money questions. Step number one, write down what is given to you. So write down what is given in the question. And do a little bit of a summary. Well, that's a really bad way of writing question. In the question. Okay, so these are the things. Because it's a compound interest question, why do we know it's a compound interest question? It says compound, compounded daily. There's no mention of the word simple interest in here whatsoever. So because of the words compound in the question, we need to use the compound interest formula. And in the compound interest formula, we're interested in these key things. We're interested in A, we're interested in P, we're interested in R, we're interested in T, and the new thing that we're learning today is we're interested in Q. So with a question like this, always write down those things there, and from the question, fill in the blanks, okay? So hopefully, when we fill in all the gaps, there'll be one thing in there that is missing, and that's the thing we're going to try and find out, okay? So let's scan through the question. So Luke wants to save up money to buy the latest console when it's released in 18 months. So 18 months has got to do with time, and with our money questions, we need to convert the time to years. So years, 18 months to years is going to be 1.5 years. 1.5 years is 18 months. I'll just write that here. 18 months is 1.5 years. Just divide the number of months by 12. That's how many years it's going to be. He estimates that it will cost about $500. So this is going to be our amount that Luke wants to save up to. It's not the principal. So in this question, it's going to cost $500, but this is how much money he wants his investment to grow towards. He wants his deposit, he wants to give the money to the bank, and he wants that amount of money to grow to $500 so he can buy the console. So A is the $500. How much money should he invest? So this is asking for how much money should Luke have to give to the bank at the start. That's going to be the principal. That's the bit we're trying to work out. So that bit there, we don't know what the principal is. If the interest rate is 4.5% per annum, so that's the interest rate, 4.5% per annum. That's the yearly interest rate, by the way. Compounded daily. So that means compounded daily, we can either remember from the table, or if we go up to the table, we just need to know how many times does that mean that interest is calculated a year. Daily means a Q value of 365. So that means, okay, let's put Q as 365 in here. So 365. Don't know why I put a bracket there. That was a bit weird. Okay, now we've got all the pieces of the puzzle. What we need to do is substitute these numbers into the formula and calculate the bit that we don't know. Okay, so let's do that. So let's go put the formula is this. This is the more, so step 2 is to substitute the values. Okay, let's do it. So the formula starts off like this. A equals P1 plus R% over Q. And I'll keep the colors the same so we can, if it will let me. Maybe not, okay. Too bad. Okay, that is our more complex formula, but we've got all the bits that we're going to put into it and solve. So the A is $500. So $500 equals the principal. I don't know what that is, so I'm just going to leave it as P for principal. 1 plus the interest rate from the question is also written here. It's 4.5%. That's the yearly interest rate. So I'm going to write it as a decimal, but you can leave the percent sign in there if you really want. 0.045. Remember, if you leave the percent symbol in there in your calculations, you've got to write it as 4.5 and then write the percent symbol, okay? Over Q. Now, Q is 365, number of days in the year, because it's compounded daily. The number of years is 1.5. That's our time value and our power. But we've also got to times that by 365 as well. All right, so this is the tricky bit. So now I've got all the parts of the pieces of our puzzle substituted into our formula, and now we need to rearrange this complicated beast in order to get the principal by itself, to work out the principal. So in order to do that, let's make our life a little bit easier for ourselves. Let's calculate what a couple of these things are. Let's just work out what's inside the brackets first and do that as a decimal calculation. So if you get your calculators, you just type this bit inside the brackets into your calculator. And while you're doing that, I'm going to write down what the next line of working out looks like. So when you type in the bit inside the brackets, you get 1.000123329. And then the power is going to be 1.5 times 365, so that's $547. Not $547. $547.5. Okay, so all I did was I multiplied the power values together, simplified the powers. So I'll just say what I did. What's inside the brackets, I've done that, is this bit, and the power up there is that bit there. And the reason for doing that, it just made the formula a little nicer to work with rather than having all these extra bits. Okay. Finally, to work out the p-value or the principal, I get the number on the other side, 500, and I have to undo this multiplication that's going on here. I have to undo it. So I need to divide the 500 by everything that's attached to the p. So the way I'm going to do it is I'm going to write 500 on the top of my fraction, and then I'm going to go underneath. I don't know if I'm going to be able to do this, so I'll give it a try. Got that straight line there. On the bottom, I'm going to go 1.000123329, and I'm also going to put at the top there 547.5 as the power. So on the bottom of my fraction, it's this thing in the brackets, but this thing in the brackets is all being raised to the power of 547.5, which is this number here. So if you do that calculation on your calculator, and if you've done the right steps in terms of rearranging it and everything, you get a p-value, a principal of $467.37. Wow. That means that Luke has to deposit, he has to save $467.37. Basically, he's got to put that amount of money in the bank right now for that money to grow to $500 in 18 months. Doesn't seem like it's going to happen. Like, it's thinking, well, that money's not growing very much, but that's just how it works. That's just how interest works. That's definitely the correct answer. So Luke would need to deposit $467.37 right now in order for that money to grow to $500 in 18 months. Okay, the final example that I've got, and I'm looking at the time because we are running out of time. I still want to do a question and answer session. The final example I'm going to do is I'm going to do it back in Microsoft Teams. So this is going to be the end of the live stream, and we're going to jump over back to Teams. The final example, I'm going to go and show you how to do a maths-based question, and then yeah, we'll do that. So if we can all jump over to Teams again, I'll set up a meeting,